Hello everyone. In this video, we will see how to build neural networks using graphical user interface of Excelsior web app. First, we need to upload a file, the data file, which should be processed and cleaned first to be used in the neural network. So we will choose very familiar MNIST data. Here the MNIST data is stored in a CSV format where basically we have flattened the pixels of the images. So each image is a 28 into 28 vector. You can see the last column is named 28 cross 28 and the first column is the label, that is the handwritten image, and the pixel is flattened from 1 into 1, 1 cross 1 to 28 cross 28. Now we want to process the file, so we will remove the header, remove any nan values and save the edited file in the backend. We don't have to delete any rows or delete any columns in this case. Now you can see the file is cleaned, the header is gone. In first column we have our output labels and rest of the columns contains our feature vectors. We don't want to use PCA right now. Let's build a neural network to see how it works on the direct data of MNIST dataset. Let's go to neural network tab and use the same file from the backend. So now it's time to add some layers to the neural network. But as we know, the first layer contains the inputs. So we have to provide number of inputs. As we know, the image is flattened to 28 into 28 feature points. So total is 784. So we have total 784 number of inputs. We will add the input layer. With only input layer, we cannot create this network. We need to add hidden layers and output layers. So we will add at least one more layer. So we will add 100 nodes in the first hidden layer and we will add activation function as relu. In the second layer, we will do the same thing. And in the third layer, as we know, there are 10 levels in the MNIST dataset, that is the handwritten digits from 0 to 9. So we will provide 10 in the output layer and we will provide softmax as the activation function. The layer is added. Now the architecture of the network is ready. As you can see, there is one input layer, two hidden layers and one output layer. Now let's create this neural network. Now we can see what type of neural network is built and how many trainable parameters are there, how many total parameters are there. In this case, we do not have any dropout, so total number of parameters is same as total number of trainable parameters. This is not a binary classification. This is basically a multi-class classification. Let's select multi-class classification. The regression is coming soon. We will normalize the data because it provides better results. We will shuffle the data while training, and percentage training data we will keep it to 85%. And here we choose NLL loss, that is negative log likelihood loss. Now default number of epochs is 2. Let's increase it to 3 and we have to provide the output column number, and we know the output column number is 1 and batch size is default is 200. Let it be 200 for now. Now the training is done and the confusion matrix for 10 variables are printed. As you can see, number of correct prediction and total number of test cases are provided and the accuracy is 92.44%. Now let's do some modifications so that we can see how the neural network behaves. We will increase number of epochs to 6 and again train the network. The network is trained and the new confusion matrix is generated, and as you can clearly see, the accuracy increased from 94% to 95%, which is an increment. Now let's test the breast cancer dataset from Wisconsin University. We will upload the file. Again do the same processing as done in previous videos and we get our clean file. Now let's apply neural network on this file. This is a binary classification as there are only two labels called 0 and 1. There are total 11 columns. The first column is the output label, others are the feature columns. So in input layer, let's add 10 because there are 10 features. In second layer, we will add 100 neurons and ReLU activation function. In third layer, let's add 200 neurons and ReLU activation function. And in the last layer, we have to add only one neuron as we have only two values to show either 0 or 1. And for the last layer, we will add sigmoid as activation function. Now let's create the network. You can see 21,501 trainable parameters, and as there are no dropouts, total numbers of parameters are same as number of trainable parameters. This is a binary classification. We will normalize the data, shuffle the data while training, and percentage training data we keep it to 85%, and we choose binary cross entropy loss for this dataset. As you can see, for binary classification and multiclass classification, appropriate loss functions are provided. Let's run it for 20 epochs. And we will decrease the training batch size to 20. Now after training, you can see the confusion matrix, and from the confusion matrix, all the training results are predicted. The accuracy is 0.9069, which is basically 90.69%. Now let's change some parameters in the neural network and see how it behaves. So instead of 20, we will apply 50 number of epochs and train it. After training, you can see the accuracy increased to 93%, which is an increment in the performance. So now let's change the number of epochs to 20 and change the loss function to MSE or mean square error. With this, the accuracy increased significantly to 94.18%. So we know that for this data set, the accuracy increases with MSE loss and 20 epochs. Let's increase number of epochs to 50, but sadly the accuracy decreases. So probably it is happening due to overfitting. So we will keep number of epochs to 20 and train the network to get the 94.18% accuracy, which is the best case scenario. You can do all sorts of experiment. Let's do one more experiment with the neural network. So we will change the loss function now, train the network, and the accuracy is 66%. So this loss function is not very appropriate for this data. Thank you.